Let's see what we could do with this first one. So you want to get the absolute value by itself. Absolute value of 2x plus 1 is less than 5, right? What'd you do next? You say 2x plus 1 is less than 5. What word should I be using here?
And.
Less than is and. And then we get 2x plus 1 with a negative sign in front is less than 5. So maybe the way to do it is to say that 2x plus 1 has to be
Greater than negative 5.
greater than negative 5. Okay, so let's see. Here I get 2x is less than 4, so I get x is less than 2, and let's see, here I get 2x is greater than negative 6, so I get x is greater than negative 3, right? And so I go ahead and draw my picture of this. And so we want to be greater than negative 3. So that picture is going to look like, here. Let's say here's negative 3. I'll put an open circle there, negative 2, negative 1, 0, 1. So here's 0, let's say. And here's 2. I'll put an open circle there. I want to be less than 2 and greater than negative 3. So that's a picture of what it looks like. Hey, could I do my geometry trick again? Yeah? What would be the center? The center would be? Negative 1/2, right? The center would be negative 1/2. And I guess the question is, can you guys see negative 1/2 in here?
Yes.
How?
You said 2x plus 1 equal to 0.
Right. Negative 1/2 is the solution to 2x plus 1 equals 0. You guys, what do absolute value graphs look like? What shape are they? Yeah, they're not parabolas. They're not really an X. A V, right? You showed me a V. Right. You get a V. I mean, if I take a quick look at Desmos, for instance, right? Let's graph on Desmos a picture of this. 2x plus 1. So I had, and they have these absolute value bars, which is nice. 2x plus 1, right? And I want to figure out when it's less than 5. So I could write minus 5. And let me go ahead and write y equals. Enter. Why didn't it do anything?
There's an apostrophe.
There's an apostrophe there. Okay, let's get rid of that. There we go. And so it is a v, right? And if we want to know when is the function less than 0, right, you could find the zeros, the x-intercepts, and just look for where are we less than that. So from negative 3 to positive 2. And when Matei said, well, I know where the center is, right, that's this vertex point out on here, negative 1/2. Okay? So you can see this very visually, which is nice. But it's nice also to understand the algebra. Okay? Now, how far away from the center to either endpoint? How far?
2.5.
2.5? And how would I get that? I guess if you wanted to do this without doing the algebra we showed you, you might have to make this move. You might have to write, let me do it in black, 2 times the absolute value of x plus 1/2, right? Factor out a 2 is less than 5. And so you get absolute value of x minus negative 1/2. That's another way to write x plus 1/2, and it makes the negative 1/2 show up here. And then how do I get the absolute values by itself? What would be the next step? What am I doing here? Dividing both sides by
2.
And so this 5/2 is your radius. Okay? So I guess one of the take-home messages is if you can write an absolute value inequality like this, we know it's a barbell with a center and a radius. And that's useful down the road in calculus. Probably the first time you ever did absolute value, they didn't show you that. But this is a helpful concept, and so I thought I'd share it with you. Okay, let's go to the other one. The other one's a lot shorter. Well, it can be. What'd you guys do first?
Subtract 4.
Okay, subtract 4. So 2 absolute value of 7 minus x is greater than, you guys got negative 3. Next.
Divide by 2.
So you get the absolute value of 7 minus x is greater than negative 3 halves. Next. Set up two different inequalities. Okay, what would they be? 7 minus x is greater than negative 3 halves. Should I use and or here? Or 7 minus x is less than 3 halves. That's what you guys are going to tell me? Okay. By the way, I'm going to point out with a little asterisk right here that we can stop now. And I'll explain why. Or do you know why? All right, let's keep going, and then I'll go back to why we could stop right there. Something to look for with absolute value. Let's keep going and see what it looks like. So let's see, we get, next step, did you guys subtract 7? No, what do you guys do next? Add x? You tell me.
Subtract 7.
Oh, okay. So then you get minus x is greater than, okay, so I have to do negative 3 halves minus 7, which is minus 14 halves. I'm getting negative 17 halves. Does that sound right? What do you do next? Multiply both sides or divide both sides by?
-1.
And when I do, I have to remember, okay, so I get x is less than 17 halves, or, and I'll work quickly through the other part. Let's see. Negative x or minus x is less than, now this is 3 halves but minus 14, so I get negative 11 halves. So I'm going to do the same trick, and I'm going to get x is greater than positive 11 halves. This okay? And now I go ahead and draw my picture. And I say, well, over here is 11 halves. I have to be bigger than that, or less than 17 halves. Now the key here is that it says or, right? Or. That means you want all these guys and you want all these guys, because either or is okay. Right? Like, let's take a number bigger than 17 halves. Give me a number bigger than 17 halves. 1,000. Wow. 9 also. I think I'll go with 9. All right, because 18 halves is 9, right? So if I plug in 9 into the equation, into the inequality, let's see if it works. 2 times, if you plug in a 9, you're going to get negative 2, but you take absolute value. So 2 times 2 is 4 plus 4. Bigger than 1? Sure is. So 9 is a solution. It's over here. And that's because 9 is bigger than 11 halves, even though it's not smaller than 17 halves. In other words, I would say all real numbers are solutions. All real numbers are solutions. And I'm going to put my little asterisk here, because I think, as soon as my screen comes back, if we go back to here, we could have figured that out. Do you see it? It says absolute value, right? So this thing I circled here. Absolute value is bigger than a negative number. That's always true, right? Because absolute value, what's the smallest it could possibly get is 0, right? So you have absolute value bigger than negative 3 halves? Yeah, I don't care what you put in for x. All real numbers are solutions. You guys with me on that? Something to look for. What if it said less than negative 3 halves? What would we say?
You'd have to.
No solution.
No solution. Absolute value by itself, less than a negative number?
No.
Right? I could get away without working that out. Now, if you work it out carefully, you could still get the right answer as we did. Right? But that involves knowing to use or in this situation and to use and in a less than situation. You guys understand? Any questions? So that gives us kind of some of the basics behind these. I should probably do one like number 7 as an example. Let's do that. So we have 2 is less than absolute value of 4 minus x, and that's less than 7. So number 7 is this, okay? Now, yeah, question?
It's 2 less than equal.
Oh, it's less than or equal to here?
Yeah.
But it's just less than 7.
Yeah.
Okay, thanks. So I guess if we're going to do this one, you could think of it as 2 separate problems, right? I have absolute value of 4 minus x is less than 7, and I have the absolute value of 4 minus x is bigger than 2. Okay?
What about the equal to?
Ah, bigger than or equal to 2. Thank you. I keep missing that. Or, if you want to be careful, you could try and work it out all together. So you either go separate or you go together. Now, I know each one of you could separate it and work it out. It takes time, it takes paper. I'm going to show you how I would carefully work it out kind of in one step. Okay? So here I go. Do I have the absolute value bars by themselves?
Yes.
I do. You with me? So that means I can take them away, and when I take them away, I get 4 minus x is between, with a less than or equal to here and a less than here, 7 and 2. Right? So there's one set of solutions. What's the other set of solutions? We want to look at the opposite of 4 minus x being between 7 and 2. Okay? So again, if I multiply everything by the negative, what happens?
All the signs flip.
All the inequality signs flip, right? So you kind of get, you could do it this way. It would be 4 minus x. I don't need those parentheses anymore. So now it's negative 2 and negative 7. But the way that people usually write these inequalities, if you write triple inequalities, is we like to go smallest to biggest. So negative 7 is less than 4 minus x, and that's less than or equal to negative 2. Okay? All right. What do I do to all sides of the triple inequality?
Subtract 4.
Subtract 4. So this becomes a minus x. Here I have a negative 2, and here I have a 3. Same thing here. I can subtract 4. Here I have a negative 11. Here I have a minus x. And here I have a minus 6. Okay? Moving along. What do I have to multiply by? Or divide by negative 1, which means what am I going to have to do? Flip all the inequalities. So let's see. This will become a 2 is greater than or equal to x, and that's greater than 3. So wait a minute, negative 3, negative 3. The way people would probably write that is that x is between greater than negative 3 and less than or equal to 2. There's a piece of the solution. Okay? And then moving on, over here, when I multiply everything by a negative, again, that'll become positive 11, that'll become positive 6. I'm going to do it in one step. Because if I flip them, then you get this. So there might be one step in between I just skipped, but I wanted to get to the answer. Okay? Yeah, question, Cassie?
Okay, for the second equation, when you first start off, you take out the negative. When you become a positive x,
The second equation here?
like you took out the negative and made it like a negative 2, a positive 4, and a negative 7, why did the x stay negative then?
Oh, I was only getting rid of this negative sign right here. That negative I got rid of. So I multiplied by negative 1, and so instead of negative parentheses 4 minus x, now I had positive parentheses 4 minus x. See it? Multiply these by negative 1, and that's how I got that. Any other questions on this? You don't have to do it all together. You can also split it up separately, do them as separate problems, and you'll come up with these two solutions as well. Okay? So that's a bit complicated. All right, moving on. We should do a few quadratics, because everything else, absolute value, I think you're okay at this point. Oh, there was the one I skipped. Well, let's get to that. So let's try one like number 11. Absolute value of 1 minus 2x is greater than or equal to x plus 5. All right, it's a bit challenging. We have the absolute value by itself. That's not the issue. But the issue is that it's not a number on the other side. It's a function. Right? So let's see what happens here. I can still go through my, my cases here, right? I can say 1 minus 2x is greater than or equal to x plus 5. And what's the other case?
Or
Yeah, or what's the other case?
1 minus 2x
1 minus 2x
less than or equal to.
less than or equal to the opposite of x plus 5, okay? Now what's going to happen? Is this an inequality you guys know how to solve?
Yes.
You're going to get x is bigger than something. Is this an inequality you know how to solve? Sure, you'll get x is smaller than something. But I want to warn you here, okay? When we split up into these two cases, we want to be a little careful about when do each of these things happen. You see, because really the cutoff is 1 minus 2x positive or negative, right? If 1 minus 2x is positive, that's when we're over here. If 1 minus 2x is negative, that's when we're over here. It really comes down to what is the number 1 minus 2x? Right? If you have a positive number, you just take away the bars. If you have a negative number, when you take away the bars, you need to flip a sign. Does this make sense to you guys? Okay. So, in other words, what I'm going to say is the magic number here for absolute value of 1 minus 2x, right? The vertex of the v is at 1 minus 2x equals 0, right? 1 equals 2x. So it's when x equals what?
1/2.
1/2. It's when x equals a half. That's the vertex. And I think if you understand that, you can really help yourself when you split up into these two cases. Give me a number bigger than a half.
1.
1. If I plug in a 1, do I have a positive number or a negative number in the absolute value?
Negative.
Negative. That's this situation. If x is bigger than a half, like if you plug in a 1, I'm in this situation. So I'm just going to make a little note of that. X bigger than a half. And then what about this case? This is the case where x is what? Less than or equal to 1/2. Yeah. I guess equal to you could be in either case. Give me a number less than a half. 0. 1 minus 0 is 1. Absolute value of 1 is 1. So do you see the difference? You want to look for, when you take the bars away, am I in this situation or that situation? All right, we'll see how this plays out. So we get, if I work through here, let's see, negative 2x is bigger than or equal to x plus 4. So negative 2x, well, I'll subtract x. Negative 3x is bigger than or equal to 4. So I get x is less than or equal to negative 4/3, right? Okay, and then working through here, let's see. 1 minus 2x is less than or equal to negative x minus 5. And let's see, I'll bring the 1 over. Negative 2x is less than or equal to negative x minus 6. I'll bring the x over. Minus x is less than or equal to negative 6. So I'm going to get x is greater than or equal to 6. Okay, so I guess my point is not made by problem 11. Sometimes, like, if this says x is greater than or equal to 6, you want to check, are all those solutions bigger than a half? Because if not, you may not have any solutions. Are these numbers all less than or equal to positive 1/2? Well, yeah, you have a negative 4/3. So these are all solutions. But here's a situation, guys, when you start getting to these very complicated problems where you have absolute value and you have functions, I'm going to say pull out your calculator, right? So for me, I pulled out Desmos today, right? Here, let's do that again. So what's our problem say? Absolute value of what? 1 minus 2x. So let me get rid of the minus 5 here. Here's my red function. Absolute value of 1 minus 2x. It's a v centered right at a half. Okay? And then the other function, you know how to graph, but I'm going to do it anyways. G of x is x plus 5, right? And so when I'm asking you guys, hey, where is 1 minus 2x bigger than or equal to x plus 5? On the picture, where are we talking about? We want the red to be bigger than or equal to the blue. Look at what our answer was. We said bigger than or equal to 6, because that's the point, 6 comma something, right? That x value is 6. Once you get past that point, red is bigger than blue. Or to the left of, what's negative 1.333? That was our negative 4/3. See it? So we can use these to really help this graphing idea. You guys follow? Okay. Quadratic. Let's do a quadratic problem. I'd like number 17 next. 17. says, well, x squared plus 2x minus 3 is greater than or equal to 0. Hint. I like when my function, or when I have 0 on one side. I like that. As a matter of fact, going to the last problem, you know, when we were looking at Desmos, the way I did it was I got two functions, right? 1 minus 2x and x plus 5. Some people would do the problem this way. They would say, hey, let's just subtract the x plus 5. Okay. And then, instead of worrying about where the functions intersect, let's just figure out where this thing equals 0. Well, it equals 0 at negative 4/3 or positive 6. That's how some people would do it. They always put both sides, get it equal to 0. So when you guys do your quadratic ones, I'm going to do that. I'm going to put everything on one side, set it equal to 0. Absolute value, though, sometimes it's easier to just take it apart by getting the absolute value by itself. Okay? So here I am. Okay, so what do I do? Well, my strategy is going to be something we talked about last week, sign diagram. You guys remember what I'm talking about, sign diagram? What am I about to draw?
Line.
Yeah, a number line. I draw a number line, right? And then what is it that you put on the number line?
Two zeros.
You put the zeros, right? Really, this is a function, right? We could rewrite this. How? We could write, instead of x squared plus 2x minus 3, yeah, you guys did a lot of factoring this week. X plus 3 times x minus 1. It says bigger than or equal to 0, right? Well, where are the zeros? 1 and negative 3. So I'm going to plot those on my sign diagram. I know that 1 is a solution. I know that negative 3 is a solution. Right there. I know that. So now all I have to do is figure out where do we have solutions in the intervals, right? We need test points. And you guys did this actually a lot last week, right? Actually, what does this problem say? This problem says find where the function is greater than or equal to 0. We want to figure out where it's positive. But we know the shape of the function. What's the shape? Parabola, opening which way?
Oh,
You know it opens upward. You know it goes through here. I mean, you've got the answer already, right? What's the answer going to be? What are some answers? So greater than or equal to 1. Or x is less than or equal to
negative.
-3. Okay, so if you understand the ideas of sign diagram and you understand quadratic or else parabolas, they become pretty easy. All right? 2 minutes left till break, and so I have just enough time, I think, for the one at the very beginning that I said I would come back to, where we have both involved. Okay? So let's try x squared. Again, this was number 28. We have x squared is less than or equal to absolute value of 4x minus 3. And I want to solve that inequality. And so I told you guys what we're going to do is we're going to split it up into pieces, right? You have 4x minus 3. But the other possibility is that x squared is less than or equal to what? The opposite of 4x minus 3. Now, again, I have variables on both sides, so I have to be careful. I want to think about, like I did before, where is the vertex? What's the magic number that you'd put in, and you could be in either case? Kelby? Yeah. Do you see how she got that? She knows that it's when the 4x minus 3 is equal to 0. And if you solve that, well, you get x is 3/4. That's the good point, right? That's the one that could be in either case. Give me a number bigger than 3/4.
1.
Okay, 1. 4 minus 3 is 1. There, I'm in this case, and that's the positive side. So this is going to be if x is bigger than 3/4, we're in this case. Bigger than or equal to, I guess. You make one of them equal to. And then the other one would be if x is less than 3/4, then we're in this case. You guys follow? So let me finish this one, and then we'll be done. So let's see. X squared minus 4x plus 3 is less than or equal to 0. Oh, okay. That one actually factors. X minus 1 times x minus 3 is less than or equal to 0. Hey guys, where are the zeros of this thing? Yeah, let me use a sign diagram for just kind of kicks here. 1, 3. Is this parabola opening upward or downward?
Upward.
Upward. So where are the solutions here? Everything between, and we want to include 1 and 3, right? These are solutions. Oh, I need to check. Are all of those solutions bigger than 3/4?
Yes.
Okay, that's good. If not, I'd have to be a little worried about what happened. Here we go, try again. X squared is less than or equal to negative 4x plus 3. So now I get x squared plus 4x minus 3 is less than or equal to 0. Ooh, I don't like that one as much. It doesn't factor. I mean, I still want to use a sign diagram idea, but in order to get the zeros, what do you need? How do you figure out how this equals 0? It rhymes with habrabrik gormlila. You guys are good. All right, so x equals negative 4 plus or minus the square root of, don't ask me to spell that, 16 minus 4 times 1 times
Negative 3.
negative 3 all over 2. Holy mackerel. I'm getting negative 4 plus or minus the square root of 16 plus 12 over 2. Wow, up here, I'm getting negative 4 plus or minus the square root of 28 over 2. I'm going to split it up into negative 4 over 2 plus or minus the square root of 28 is the square root of 4 times the square root of 7 over 2. Wow. Negative 2 plus or minus. Now the square root of 4 and the 2 are going to cancel, so I get the square root of 7. So what's interesting here is if I take a calculator and if I type in negative 2 plus the square root of 7, right? So if I type in negative 2 plus, oh, I don't have the right calculator here, guys. Advanced panel, there we go. Square root of 7. I'm getting 0.64, right? That's with a plus. Is that less than 3/4? Well, I guess it is, so I'm okay there. Okay? So you're going to get from negative 2 minus the square root of 7 to negative 2 plus the square root of 7. Okay, we want those solutions. And we want to figure out where are we less than or equal to 0. Well, I guess we're going to be less than or equal to 0. Again, this is a parabola opening upward. So in between here, in between negative 2 minus the square root of 7 and negative 2 plus the square root of 7. Okay? Wow. So everything between 1 and 3, and everything between negative 2 minus the square root of 7 and negative 2 plus the square root of 7.